The weird thing about a deck of cards is that you have joint and disjoint sets happening all at the same time. So that's why it will show up perhaps on quizzes and tests. So just be prepared for it. So a deck of cards, you need to know that half of it is red, right? So we've got our 26 red cards and our 26 black cards. Okay, so we've got red 26, black you have 26 there, which makes it altogether 52 cards in a standard deck of cards. So we don't have jokers here. Okay. And basically, if you start from this, you have your king, queen, jack. Okay, and then you've got 10, 9, 8, 7, 6, 5, 4, 3, 2, ace. Okay. So every single number, or if you think of the face cards, there are 4 of each, right? This way. I hope that makes sense. And there are 4 suits, 4 rows, so to speak. Right? So you've got your diamonds, and there are 13 cards in diamonds. Then you've got your hearts. There are 13 as well. Spades. I always mix spades and clubs. Is that spades or what? Any card? Is that spades? Yeah. Okay. Any card players? Yeah. Spades and clubs. And there are 13 of each as well. And that makes up your 52. In all of these here, all of the kings, queens, and jacks are normally referred to as face cards. It's getting a little busy, right? I know. Face cards. So there are 12 of them. If you think about it, there's 3 for every suit, and so 4 times 3 is 12. So I'll just write down 4 suits. And the nice thing is you have a study sheet, right? So you can make something like this on your study sheet, but make it very small. Maybe if time allows, I'll show you my short version of making a deck of cards a little later. Okay. So imagine this scenario where U, the universal set, is just all the cards in your deck of cards. R would be the reds. B would be the black cards. H would be all the elements or all the cards with a heart. D would be your diamonds. C would be your clubs. S would be your spades. So lots of stuff happening here. Okay. If I were to ask you, use proper notation to express the set H. So by proper notation, okay, you got to be very careful. We want the squiggly bracket. So it actually wants you to list all the elements that are in there. Notice that there's no N in front of it. It's not asking the number of elements, it's just the elements themselves. So do you remember what needs to happen when you state your elements? There's 2 criteria you have to meet. It has to be arranged, right? So alphabetical or numerical. And you can't have repeats, okay? So that's important. So if you pay attention to that, then you should be fine. Okay, I'm actually not so sure if the province has a problem, but I will go A, J, K, Q, right? So ace, jack, king, queen, okay? And then I'll just go 1, 2, 3, no, not 1. My bad. So this would be ace as your 1 technically. So this would be 2, 3, 4, 5, 6, 7, 8, 9, 10. Squiggly brackets to close it, you're done. Some of you will remember the set notation for domain and range. That doesn't mean anything to you. We'll get back to that when we do functions, but we also use squiggly brackets at the end like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've got 13 cards, so that'd be good enough for me. Okay. So number of black cards would be 13. 26. Number of red cards would be 26. Number of hearts, that would be 13. Number of spades, 13. Okay. And I'm going to throw in a curveball in here. Okay. Let's see if you remember. If I asked you this, how would you figure that out? What does that even mean? The complement, so the translation would be number of cards that are not hearts. 39. Okay? The best way to do this is to take your universal, which is 52, and just subtract the hearts from it. Remember, it's saying, I want everything that is not a heart. Okay? So that could be called the heartless set, right? If you wanted to do that one. All right. So curveballs every once in a while. To be honest, is one of the trickiest units to prepare for. Like it's always like, what does the province really want? So I'm trying my best here to like think the way they think based on all the exams I've seen before. True or false? Explain if it's false, right? So what is this saying? Is H a subset of B? H stands for hearts, right? Would hearts be a subset of black cards? Because hearts are all red. Okay, so this would be a false. And you can just say all hearts are red. Okay, that would be sufficient. Because for something to be a subset, every single element in it needs to be also in the other one. Okay. Is the spades a subset of the black cards? True. All spades are black. Would the clubs be a subset of the diamonds? False. No club is also a diamond. Okay, there's just no way that can be true. Would the diamonds be a subset of the red cards? True. That's true. Okay, so sometimes they will ask you for something like that. Here's the most classic Venn diagram possibly for a deck of cards. You're with me? So basically, I will do the box at the end. Okay, so I'll just say the big division is black cards and red cards. Okay. They never touch, correct? There's no black card that is also a red card. So what do we call two sets that have nothing in common? Disjoint. What's the other? Mutually exclusive, right? Mutually exclusive disjoint, same thing. So you've got 26 here, 26 there. And then within the black set, you've got your spades. Okay, that would be here. And you've got your clubs. And how much are in each one of them? 13, correct? And here you've got your hearts and your diamonds. 13 as well. Now we put the box around. And the U would say 52, correct? There are 52 cards, 26 black, 26 red. And here you can clearly see that as the spades would be a subset of the black cards, the clubs would be a subset of black, right, because it's inside. Same here, hearts is a subset of red, diamonds subset of red. There are no outliers. Okay, so in this case there are no outliers. So there are disjoint sets, and at the same time we also have subsets. So this is what that would look like. Okay, so sometimes all I'm going to ask you is to sketch it. I don't need you to actually list everything inside, just to kind of give me an overview of what that would look like. Page 6. Let's go to page 6. That one I assigned to you. Terminology is going to be your friend or enemy. Depends on if you know your stuff. Okay. Let U be the set of digits from 1 to 15. What does inclusive mean? It means it includes 1 and 15. That's all it means. Okay. So it's including 1 and 15. O is the set of odd numbers. T is the multiples of 3. I did post the key to this, I believe. State all sets using proper notation. I think I'm just going to show you this because it's going to take me too long to actually write it out. Okay. So 1 to 15, that should be fairly straightforward. Your O's are the odd numbers within this set, of course. So these are all finite sets. Okay. T would be the multiples of 3. So multiples of 3, it means if it says multiples of 5, let's say you start with 5, you go up by 5. So multiples of 3, you start with 3, you go up by 3. And so it stops there. Okay, so this would be probably 1 mark for each. State the complement of each set. So the complement O naught, what does it, like you know that it's the odd numbers, right? So if it's not odd, then you want all the even numbers. So sometimes just think about it and it will make sense and it'll be easier for you. The complement of T, there you probably have to think a bit more. So I don't know if you see that I kind of cross off T, and then I'm left with whatever is not in T. And so that's your complement. Okay. State the number of elements in each subset. So N of O would be 8, so you basically just base it on previous work that you've done. N of not T, I just take the universal, subtract T. N of not O, I don't know if oh yeah, I did ask you for it, yeah. So I did ask you for all this, so that's there. Are sets O and T joint? And I say that they're joint. Why? I highlighted that. They do have things in common. So there would be an overlap on the Venn diagram, as you will see later on. Did you understand what this meant? Some of you may have been confused by this because I haven't used that notation yet. And that's okay. Don't panic too much yet. It will come, maybe some of you Googled it, but it's the intersection. That's what that means. So it's basically if you were to state the intersection between the two sets, O and T, it's the overlap. Those are the elements that belong into that one. Okay, so this is how we refer to it. Okay, so don't worry about it too much yet because there's more of that coming. This is your Venn diagram. Here's some warnings I'm going to tell you. Never forget your outliers. Okay, remember outliers. Okay, so that is probably the most common mistake that I see. The beautiful Venn diagram is there, the box is there, everything is there, but you forget about your outliers. So when you're all said and done and you've placed everything in, always wonder, are there some elements that I didn't use? Okay. And my Venn diagram, I overlap and I always start with the common elements and then I do everything else. So make sure you practice this. If this isn't filled in right now, strongly recommend this would be to me like a very basic skill right now to just be able to plug everything in and see where it goes. Okay? This one, I had a few questions about this one. I appreciate questions. Okay, just bring them. So make subset of O's of set O and set T, and you can call them P and Q. So yes, you could make, as long as the subset you're creating grabs everything from that set, right? So O, let's say O, you can grab any number and just put one element in it, and this is considered a subset. You could grab any 3 you like, any oh, I grabbed different 3's, right? So it doesn't matter as long as you don't grab all the elements, because then you're making the exact copy. That is not acceptable, okay? So you have to create a new set that has fewer elements, and so that's your choice. There's lots of answers there. Same with Q. I just picked any 2. I may have picked just 1. I actually picked 369, right? 369. So anything, just grab it from them. As long as you don't grab from here or outside. For example, for Q, Q is a subset of T. You are restricted to whatever is inside of T, right? So you gotta grab from that list. You can't grab from anywhere else. Then it's no longer a subset, okay? Think of it this way. You should be able to grab, so let's say this is the subset I created out of O, 157. If I were to circle them, can you see that it's obviously a subset? Because it's inside the other one. So another way of checking, okay? You're smart. What am I doing? I should just assume you know, right? Anyways, don't assume that. That's always let's go to 7. Okay, I just read, they always send us, pay attention to this one, they always send us a memo telling us, kind of giving us a hint, make sure you students know this. I've learned to listen to that memo very carefully. And they asked us one more time to remind students to be aware of what is a natural number, right? What is a whole number? What is an integer? What are real numbers? And prime numbers. That one is a very, very classic example, prime numbers. Prime numbers are only divisible by 1 and itself. Okay, so you need to know. I would just have that on my study sheet, to be honest. This one is a nice diagram here. Natural numbers are whole numbers. It says it here too, just so you know. Whole numbers that start with 1. Whole numbers include all natural numbers, but also have 0 included, right? So whole numbers start with a 0, 1, 2, 3, and so on. It's all positives though. And then integers, you can go to the negative or the positives, and it includes 0, right? So negatives and positives, still whole numbers, okay? Real numbers, that's when everything goes, right? So real numbers, it still has integers and whole numbers inside of it, but it includes all decimals. You could even put pi in there if you'd like. Anything goes when it comes to real numbers. So real numbers is saying everything is included, right? And then don't forget about prime. I'm going to highlight that one. I also ask a lot about that one. Don't forget your prime numbers. If you want a few more, if this isn't going to be enough for you to know that it's only a number that's divisible by 1 and itself, then I'll give you a few more. So prime would be 2, 3, 5, 7, 11, 13, 17, 19, 23. I think we're good. Okay. 29 would be the next. Okay. So these are your prime numbers. Make sure you have a list of the first couple of prime numbers there. So I would say this whole thing, make it small. Like this, I don't know if this helps you, then stick with this. But I would want you to know this chunk here. Some of you are only going to need to see this, not the definition, right? So if that's all you need to see, then way to go. You're good to go, okay? But make sure you have something there. And I do have a few exercises there, but I'm going to leave it for another day. Okay. I'm going to go to page 10 now. And now it's getting a bit more down to what this unit is all about. So I kind of spent a lot of definitions, terms, some examples, But now we're going to go to page 10. And if you have a highlighter, a few highlighters, this is where you want to use it. I'm going to use a lot of color here to give you a sense of what this could look like. Right? I do use a lot of color here, so if you want to follow my format, then you do that. Okay. So here's notation. Exploring the relationship between the sets and their notation. So here it is. I kind of alluded to that while we were going through the examples. A and B. This is, you can call this and it's representing the intersection of A and B. Right? So think of, when you see this, you think of the intersection and maybe the word and. So when it's these sets are joined, it would be referring to this area right here. Okay. What about here? Is there any intersection here? Is there anything that they have in common? No. No, this would be a disjoint set. So here nothing gets highlighted. It would be a null set. Okay, null set. Here the and, what set B and A have in common is this. It is B itself. Okay. So I will say this is an example of when they're joined. This is when the sets are disjoint. They're called mutually exclusive. It's kind of like your red cards and your black cards. There's nothing that they share, right? So maybe I will add that here. Underneath the middle, I will just say that A and B is like this. It's null set. There's nothing in there. And so I will highlight underneath so you can kind of, it's like, why is there nothing highlighted? It's because there is nothing that they share. So there is no and. Okay. Okay, next. This is A or B or U. Okay. I'm going to use a different color on this one. I like things sticking up. So union, so you think of union, and you can also think of the word or. Okay. Later on, you'll see that this will come full circle, okay? When I do word problems later on, it's like, oh, okay, now I know what this means. So elements that are in A and B are combined but not repeated, okay? Note that elements outside the sets are not included, okay? So in this case, the union would be, as you can tell, is uniting it. So it's almost like you're making just one big set like this. Okay. So the union here, don't go too dark, because then it's gonna bleed through. I'm telling you that already. Okay, so that'd be the union there. In this middle where there's disjoint, it's just saying, hey, this one uniting with this one. So it'd be all the elements in both of them. We don't have to worry about repeats there because there are no repeats. And then over on this last one, it would just be everything, A and B combined. So it's just the entire thing like that. So that's what union means. It would result in all the elements that are in this case, 2 sets, but it could be 3 sets, it could be 4 sets. We don't go more than 3, by the way, not in this course. And then we have, I'm going to use green on this one, you do whatever you need to do, A backslash B, okay? It reads A minus B. And it refers to elements that are only in A, not in B. That's what that means. You can say B minus A if you want to, but this is A minus B. So in this particular case, it would just be this section here. You want nothing to do with B. you just want this section right here. Over on this one, obviously, if you just highlight A, you don't even have to worry about B because it's not even touching. Over on this one, you just want A, you do not want B, so you just basically highlight everything around. So it'd just be the elements that are surrounding. And last one is orange for me. You know what? I will, if you don't mind, sometimes I use arrows like this and refer to this green section. Yes, it's A, not B. Okay, this is A, not B. Same here. A, not B. And the last one, so 4 different notations, right? A naught, right? I think you already know this one. A naught reads all elements that are not in A. All. So you go universal minus A, so you think of it not A as just cover up A, and you highlight everything else, including the outliers here. Right? Some of you are like, I'm not highlighting. I got this. All right. You do you. Okay. That would be not A. Same here. It's a lot of work, but it will pay off. So when you look through your notes, you're like, oh. There we go, that's not A. What about the last one? Just the universal, yes. Because B is inside of A, so you saying not A also eliminates B in this case. There we go. Just a reminder, if you're ever asked to find a n of not A, it's basically just take your universal and subtract the number of elements that are in it. Just a reminder. I will also introduce another one because it's kind of coming back later. Once you've got this down, I'm going to ask you to go to the OR section. So the OR section is the union. So it's like whatever these two sets have in them, well, you want to combine that. So to refer to the outliers section here, make sure you add this to your notes. To refer to the outside, we call this A or B not. I hope that makes sense. That would be the outliers. So you unite whatever sets you have, and you just put a not in front of it, then you're referring to whatever is outside any of the sets that are involved here. So I'm gonna, I don't have any, I have blue, there we go. I think this one is important to, as you flip through your notes, do not forget about that one. Okay. Now we're ready to take it up a notch. So notation, I know it's a little annoying, but you're gonna get really good at it. So now that we have our notation figured out, let's go to page 12. Don't let this scare you, okay? Like you'll be fine. You just have to I have to break this into pieces, and then there's something that we call that governs, okay? The rules that govern Venn diagrams is governed by this principle, the principle of inclusion and exclusion. I call it pi, okay, in short. And so we're going to start with 2 sets, and then we're going to take it to 3 sets. Right? So that's how it goes. Let me just get my notes in order here. And so when I refer to A not B, it's just referring to this section here. So I'll just write that out here. The word problem, because this is where we're going, this is saying only A, this section right here, it's that crescent here. Okay? You can also call it A, but not B. That is important. At the same time, if we come from the right side here, notice how it's written differently. It's B, not A. So it's only, like the key word here is only B. B, but not A. So some of the questions are going to be very cheesy. It's like, who has a cell phone plan but does not have a cable plan or something? Then it's obviously referring to, right, this crescent. It's the crescent. And then the middle, this one right here, let's put an arrow right into that center there. Both, or have both. Both A and B. Okay, so that's that. How do we refer to outliers using notation? It's A or B, and you can do brackets and a little tick here or a bar across. They both mean the same, so I'll kind of jump between because they asked us to make sure you know both. Okay, and here's where colors are going to be very important. Okay, I'm going to refer to this chunk here. I'm going to give that a green. And I'm not going to fill it in this time, okay? So don't worry about that. I'm going to use the different color to refer to this middle section. And a different color yet for the outside. Make it prettier again. Yes. What a waste of time, some of you are thinking, right? Sure. I like colors when I'm about to talk about the next part, the formulas that I'm about to throw at you. Okay, so here we go. Knowing this, okay, knowing the breakdown here, we know our outliers, the middle, we know how to refer to every section here. If I wanted to put a number here, number of elements, I have to add the green plus the orange section. Okay, it's very important. Some students think that A is immediately just the crescent. That's wrong. A, that number here, is going to be involving these two. Whereas B, if you come up with a number out here, it's going to be whatever color I have for it, plus orange. I know it's stressful, I know. but then later on we can just always come back to this and we're good to go. Okay, now the principle of inclusion and exclusion, right? This is visually what you should be thinking of before you look at the formulas, because there are 3 and they're all true. I don't use them all. I just use the most common one is this one. This is the one I'm going to be using the most. But think about it this way. It says the number of elements in the union between A and B can be found by taking the universal and subtracting the outliers from it. Okay? So these are the outliers. So let's go back up here just to make sure you understand. Okay? So the union would be, if I were to combine both of these sets together, if I wanted to know how many elements are in here, I take the universal, so I take that number that'll be way up here, and then I subtract the outliers. I'd subtract whatever is outside here, and then I will be immediately left with everything that's inside one of those sets. Okay? All right, next. The other thing that is true is the union of A and B can be found by the number of elements that are in there is by, here's where the colors are going to come in. I wish I could do all, I want all on one there. It's the adding the green part, adding the orange part, just this one. Oof, I messed up. It's actually this, right? This part is, can't make it through one lesson without mistakes. That's just sad. Okay. Sorry, guys. So it's basically adding up the crescents and adding up the middle. If you add up those 3 chunks coming across, you would come up with the union, like all the elements that are in that union. Okay? Got it. Next. This one is the most common one. This one right here, the third one. What is the union? So they're all saying the same thing. They're all trying to get at the same thing. But the union is taking A, pay attention to this one. You take all of A and you take all of B and you got to subtract the intersection from it. And why is that? Okay? This is the intersection. Because otherwise you'd be double counting. Let me see if I can have this going. If you did not subtract, you'd be double counting. Because think about it, if you add up all of A, you're adding this orange part as well. And if you add all of B, you're double counting this one. That's where this is being subtracted to account for that. Okay? Is your head hurting already? Yep. And here's an important concept as well, right here. Note that N of A union B does not include the outliers. And it refers to the elements that exist in at least one of the sets. So that is very important, this part right here. So I'll say that for all of these, I'll make an arrow coming out of all of these, and they will merge and point you in that direction. That when you do this, you're always trying to eliminate the outliers. Okay? You want to subtract the outliers from it. And now we're going to jump in using this to our first problem. Let's go to, I'm going to skip a few pages. I'm going to take you straight to 15. 15. Okay, here's the good news. You don't have to use these formulas necessarily to solve the questions. That's the good news. There are other ways of doing it, and I will show you some tricks every once in a while, but I'm not sure if the province is going to ever throw that principle of inclusion-exclusion formula at you. If they do, I want you to be able to work with it. Okay? So here it is. Let's read this together. During the pandemic, a school sent out surveys to 50 homes asking what types of devices were available to students. 30 students were able to access a tablet, 25 were able to access a computer, and 5 students had access to neither. Okay? First question says, draw a Venn diagram, fill it with the info provided. Okay? So, in this particular instance, what does the 50 represent? That's my universal. That's what governs. That's the total I can possibly have. So in this case, they actually gave me this. Okay, and T is the set T. C, students with a computer is set C. So let's draw this. What does this look like, the Venn diagram? You go like this, and then we go like this. We're not 100% sure if there's going to be anything in the middle. We're assuming that it could. So we're just going to call this T and say 30. And this is going to be set C, and we have 25 in there. And then we're going to actually make our Venn diagram like this. And the universal is known to us. That is 50. Where would the 5 go? 5 students, what's that? 5 students had access to neither. These are our outliers. Does that make sense? Yes, I actually want you to right away say that these are the outliers. And I'm going to say this. If I asked you for a notation for that, you would say that T union C not is equal to 5. So where does the 5 go? I don't know why, but I always put them down here. Even though it doesn't matter where you put that as long as it's outside of the circles. Okay. All right. I can tell you already that you're going to have to fill out, how many sections are there that need numbers right now? 1, 2, 3. There are 3 sections that need a number. Okay. So let's see what B is asking us for. How many students were able to access both a tablet and a computer? Show work. That question is asking this. It's asking that. That is unknown to us. And that is the key to unlock everything else. You need to know the intersection here if there is anything. So we're going to call this X. Okay. That's going to be our unknown. So I'm going to show my work here. Pi. And this is answering part B. I'm going to use pi for this. It's asking for n of T union C is equal to n of T plus n of C minus n of T and C. And you're going to have those formulas on your study sheet. Which one am I using of the 3 that I gave you before? It's the bottom one. It's the one that I call the most popular one. Okay. So this part right here, the union, never includes any outliers. Pay attention to that part. So you need to start this section as follows. 50 minus 5. You're going to take away the outliers. And that's going to be equal to 30 plus 25 minus, do you know what this is? We have no idea, so we're going to call that x. And I think at this point you will realize, oh yeah, I'm just going to isolate for x, and I'm going to figure out what it is. So 50 minus 5 is 45. 30 plus 25 is 55 minus x. I'm going to subtract 55 from both sides. And this cancels out, right? So you end up with negative x. 45 minus 55 is negative 10. And now you just need to divide both sides by negative 1. X is equal to 10. That's showing your work. But let's answer this properly. We determined that X is the AND section for me. So 10 students, what does it say? Had access to both. And now, before you answer anything else, folks, chances are you're going to now you're going to be able to fill it in the rest. Trust me. So let's put the 10 in here. I'm going to use a red pen though. I'm going to say x is equal to 10. That's very small. Sorry about that. Which means that this section right here, the crescent, is going to be what? Both of these have to add up to 30. So this would be 30 minus 10. That is equal to 20. You go over to the other side to just get this crescent here. It's 25 minus 10. You're going to subtract the 10 from it, and that leaves you with 15. Before you start and answer any more questions, we want to check if all these add up to 50. If you don't, you made a mistake. 20 and 10 is 30, plus 15 is 45, plus 5 gives us the 50, correct? Now you're on the right track. And this is I'm just going to tell you, the middle is the most important part. Find the middle, move out. Find the middle, move out. And there's going to be some nuances there, but you'll know what to do when the time comes. Okay, so C. How many students only had a tablet available? Let's write the notation. Only a tablet, so be tablet, not computer. That's a wake-up call, right? Anyways, that's 20. So 20 students. Okay. D. What's D asking? How many students only had a computer? I need you to be able to do both. Answer the question as is, but also rewrite it in using the proper notation. How would you write this? Only a computer, so C, not T. If you make it /, I'm going to kind of close my eyes. It's not a big deal, but so in that case, we're wanting only computers, right? So 15. So 15 students. So technically on a test, if you just told me 15 students, I'd be fine. But if on a test I tell you write this statement using proper notation, then I need you to be able to do this. That's all. Okay. E. How many students had at least a computer or a table? Sorry, I meant to say tablet. I made that one just after the pandemic, so I guess Anyways, it's a tablet. This word right here throws students off. Had at least a computer or tablet available. It is actually asking for just unite this. Unite the sets, just add up the 3 sections here, and that's all I want. They had at least a tablet or a computer, or they had both. That's what that is saying. So I'm just gonna tell you that that's asking for T union C. There are several ways of answering this. You just go ahead and go 20 plus 10 plus 15. That would be 45. Or, how else can you answer that? You can go take the universal set and subtract the outliers from it. That'd be 50 minus 5. So everything goes as long as you know how to get there. So sometimes it's frustrating, sometimes it's not. Okay, so I'm gonna get you to work after this. So I'm telling you this, not every question is gonna be exactly the same. And if you're frustrated with that, I'll win you over to my side, right? You're gonna be okay with it after a while. Mr. Dirksen, what are some scenarios that I could be facing? What is different? What's going to be different? Well, it could be, listen carefully, it could be that the question flat out gives you the middle. It just flat out gives you this. So they could have said 10 students had access to both. Oh, that number goes here. Right? It could have said 20 students had access to only a tablet. Would the 20 go here? No. The word only indicates that the 20 should go in here. Okay? So in that case, if you get the middle and you have this, you would add these up to get the 30. So you're going to just have to look carefully at your diagram and ask yourself, does it make sense the way it's going? And I'm going to stop because I know if I just keep talking, you're going to be like, stop talking, right? So let's go to 16. And, 17 kind of repeats. So I'm, for now, just going to say 16 and 18 for now. Okay. Yes. 16 and 18 for now. So I'm going to go page 16 plus page 18. Because at 17 is a repeat. You already did that one. But I do have different notation in there. But for now, I just want you to focus on word problems. So try this one, please. And I'll be coming around.